In this video, I'll be talking about the problem Big Barn. So in this problem, we're basically required to find the largest square in this chart that doesn't contain any of these trees. So for example, here you can choose something like starting at this point all the way to this, or something like that. So here we'll use dynamic programming to solve this problem. First, I'll reading the input and set all of those set the positions for those ones that have trees to 1. So this will mean that there exists a tree, and if it's empty, then it will remain as 0. Then we will use dynamic programming, and what we basically want to do is check for the previous 3 positions. So I minus 1, j minus 1, I, j minus 1, and I minus 1, j. So what this does is, for example, let's look at this position. Then it will check it will find the minimum of these 3 previous positions that we got, and find the minimum of that, because then that means the minimum will mean that there's either an edge or there's a tree blocking the position, preventing it from making a bigger square. So we will always choose the minimum of that. For example, here, this one will have 1 because its minimum is 0. This one will have a DP value of 2 because of this previous one. Actually, this one will have a DP value of 1 since it's just 1 square. This one as well. So when we are looking at the space at 2, 3, we will be able to get the minimum of these 3 values. And the minimum of these 3 values would just be 0 because it's this one here, which represents a tree. So this is correct, and then you increase it by 1. So then this means that the maximum area we can get with this is 1. So we always think of this as the bottom right corner, because we're starting at the top left all the way to the bottom right. So then when we're looking at this 3, 4, the position at 3, 4, we will get these previous ones, and for this position at 2, 4, it will have a side length of 2, and this one has a side length of 1 just itself, and this one also has side length of 1. So then when we're looking at 3, 4, we'll get the minimum of those 3, which is 1, and increase that by 1. So this is the new side length, and which is correct because the new side length is now 2. And so every time we'll just loop through each of these coordinates, get the minimum of those, and then increase this by 1, meaning that because we've extended 1 more length. Finally, we will compare get our optimal answer. So just compare all of the DP values at different positions. Finally, get the maximum of that, and you can print that out.